Okay, good morning. Today we'll be doing differences and sums. Of cubes. There's music in the next class, always fun. So we're gonna have a little soundtrack, you know.
Free chips and donuts in the next room.
Is that like a movie set? Is that how they do it? Yeah. Coffee and donuts. Like trailer A.
No, Mr. It's please hold while we transfer your call.
Oh right, it's hold music or elevator music.
Yeah, elevator music.
Yeah, I don't know about you. I'm in the elevators. I'm like. Ding. Bye. Do you guys say hi to people in elevators?
Yeah.
Cool. Me too. They like it. They're like, it's good. It's a good connection society.
What's up? You're in like a hotel or something, they get all mad at you.
Okay, so let's get into it. One question for you. Yay math?
Yay math!
Yay math?
Yay math!
One more time.
No.
He's gonna.
Okay. So in a survey before the class, only 0.5 people has seen this so far in the room. Yeah, you.
Oh.
Yeah, you're the 0.5.
You only have.
You're half person. It's a floating body. So we have done differences of squares, and now we're going to do what's called differences of cubes. All right. Notice that there's two terms here. There's a minus, and this is a perfect cube. Is this a perfect cube? What is perfect cube? As in, something times itself 3 times makes 64. What number times itself 3 times makes 64?
Maybe like
4.
Maybe like 4?
21.3.
No, like 4.
No,
As
20.
in, yes.
Maybe like 4 is correct. Yeah.
Oh,
4 times 4
4 is the
is
right one.
16. And 16 times 4 is 64. So this is a difference of cubes. That's correct. Can anyone, remember we had a discussion. This is a what degree function? Third degree. So how many answers or solutions will have? 3, correct. There's 3 solutions here. Real, imaginary, or both, or you know, all those combinations. So if there's 3 solutions, can anyone say what one of those solutions is right off the bat? Yep. Well, what one of the solutions is?
4.
4. 4 would be a solution. Because if you put 4 in here, 4 times 4 times 4 is 64. 64 minus 64 is 0. So that's one solution, and we need the other 2. And I'm going to teach you how to do the other 2. Alright, so here's how it works. If you identify a difference of cubes, now that we've identified it, you need to come up with the following mnemonic device. And that is minus, minus, plus, plus.
What?
Write it down. Minus, minus, plus, plus. Stay with this, guys, please. Thank you. Ow! I snap out of enthusiasm, not out of disrespect.
Enthusiasm.
I see. I didn't get any disrespect there. So minus, minus, plus, plus is the mnemonic, all right? And how it works is the problem will have the first minus, and the solution will have minus, plus, plus. I'll explain in a second. So the next step is to rewrite this as a result of 2 cubes. So I'm going to write it like this now. Cubed. Cubed. So rewrite it as a product of, or a difference of 2 cubes. Okay? So this one's pretty straightforward. What goes in here to result in x cubed? X. And what goes in here to make 64? 4. And now what we're going to do is, now that we wrote it as a difference of cubes, we're going to call this the first term. We're going to call this the second term. The first term is x, second term is 4. Okay? And now we do equals. Okay. Make a parentheses for 2 numbers here, and 1 for 3 numbers, so a little bigger over here. All right? And now, I know, the music's kind of just making me relaxed.
Hebrew.
Here we go. Notice, This is a difference of cubes, so it's minus, minus, plus, plus, and here it goes. The problem has the minus, here's the second minus, here's the plus, here's the plus. Minus, minus, plus, plus. The first minus is in the problem itself, all right? And then the following three signs are in succession after it.
What is the,
What goes in here?
like, what's the plus plus?
There's going to be a term here, and a term here.
Um,
I'm going to do that. But first, the signs. And it always follows this pattern. If you see a difference of cubes, I'll get it. If you see a difference of cubes, you know that this is the mnemonic, minus, minus, plus, plus. First minus in the problem, second one here, plus, plus. Question?
So that's always going to be it, right?
Right, for differences of cubes. This is the difference of cubes sign string because it starts with minus. And then we're going to do the sum after. All right? So now let's talk about what goes in here. Follows the same pattern every time. Here is the first term. What did we say the first term is? X. So x goes here. Here is the second term. What goes here? 4. Okay. Here's the first term squared. What goes here?
X squared.
X squared. Good. And I like to do the last one. Here is the second term squared. So what goes there? 16. 4 squared. 16. And the middle one is the first term times the second term, which is this times this, which is 4x.
I've heard this song before, that's why it sounds familiar.
Yeah, they're all singing. It's nice. So now it's factored. Now it's factored. If you were to FOIL this times this, it would result in x cubed minus 64.
Why don't you factor the other one either?
This can't be factored.
Because of the plus.
Oh, yeah.
It can't be factored, yeah. Every time, this will not be able to be factored here. Okay, so now that we factored it, we can set these two equal to 0. So this problem results in this. So we can rewrite our thing. X minus 4 times x squared plus 4x plus 16. I wonder how the music will play on the camera. It's funny.
They're probably not going to hear it.
No, well, we talked about it.
What happens if in the beginning, like, the number isn't, like...
A perfect cube, then it can't be factored.
Prime.
It can't be factored.
So it's like 8?
Is 8 a perfect cube?
Yes.
Yeah.
How is it?
Oh, yeah.
2 times 2 times
Times
2.
2 times 2.
What about like 17?
17 can't be factored.
It
Right.
sucks. So what do you
So
do?
we have to do it sucks. Man, I want to factor so much, dude. You just can't do it, right? So differences are sums of cubes. You have to identify when you see cubes. All right, so now here we go. Don't we set each factor to 0, right? So we set x minus 4 equal to 0 to solve. So x equals 4. So x equals 4. And then we set this to 0 as well. So again, that's our one solution. We already identified it. Now we set this to 0. And hold on to your horses.
It's okay, I don't have any.
What method would you like to solve here? I'll tell you right now, these second parts can never be factored. Can never be factored, it never works. So what are some other
Quadratic
methods?
formula.
Quadratic formula works.
Completing the square.
Completing the square
Quadratic
works.
formula, quadratic formula.
We're going to do quadratic formula for another one. Let's do completing the square for this because it's going to be a lot simpler. So completing the square, we remove the 16 from both sides. Okay, I'm going to bring it up here a bit.
Mr. Do, we haven't had a visit from the dandy eraser.
I know, the dandy eraser is on hiatus.
Hey, that was a vocab word last
It's
time.
on leave of absence.
Leave of absence, yeah.
Hiatus is our vocab word.
A long ass.
There we go. So there we subtracted 16 from both sides. And then we need a new c value. So what do we do to b?
Negative half.
Half of 4 squared is
4.
Half of 4 is 2, squared is 4. So we add 4 to both sides. What's up? You okay?
Yeah, he just said something which made me gasp.
Oh. Okay, now that we have x squared plus 4x plus 4, we're allowed to write it in this fashion now. What goes in here? X plus 2, right? X plus 2 squared is the same as x squared plus 4x plus 4, if you were to FOIL that out.
Yeah.
X plus 2, x plus 2 equals 4 plus negative 16 is what?
Negative 12.
Negative 12. Hiccups are funny. Okay. Alright, keep it cleaning, keep it cleaning. Alright, and we square root both sides. Alright. X plus 2 equals. Alright, what is the square root of negative 12?
Take out I.
Take out I.
And do 4. You can do 4.
2 root
2 root 3. Yeah, 2I root 3. And is there anything missing from the 2I root 3?
Plus or minus.
You need to bring the 2.
Right, and now we bring the 2 over by subtracting it on both sides, and we're done. X negative 2 plus or minus 2I root 3. You guys are doing great. You're rolling with it well, you know. Okay. That's it. 3 solutions. 4, negative 2 plus 2I root 3, and negative 2 minus 2I root 3. Those are the 3 solutions. Questions? Not bad, right? Watch the second one. Second one will be easier, okay? Okay. Is this a difference or sum of cubes? It's a sum of cubes, right. This is a sum. This is a perfect cube. Is this a perfect cube?
Yeah.
What times what makes it? 5. Okay, so let's first do our thing where we write it as a result of cubes. So over here, cube plus cube.
How do you find if it's like a perfect?
Good question. You get familiar with them. You get familiar with it. 2 times 2 times 2 is 8. Right? What's 3 times 3?
27.
3 times 3 is? 9 times 3 is? 27. So you get familiar. 8, 27. 4 times 4 times 4 we just did was 64. 5 times 5 times 5, 125. And that's pretty much the bulk of the ones you'll see. 8, it might be good to put them in your memory, you know, like 8, of course 1, 8, 2, 2, 2, 3, 3, 27, 64, 125. These are good to kind of get used to, especially for SAT as well. Okay, so first term and second term, x and 5. Okay, what was the previous sign?
Minus.
Minus, minus, plus, plus. Bring down this. Plus, plus, minus, plus.
How do you yeah.
You have to memorize it. Yeah.
Memorize what?
This.
There's only 2, right?
There's only 2.
So if it's for how do you subtract?
So you can put them both. Minus, minus, plus, plus, and plus, plus, minus, plus.
How are
There
you
you go.
gonna know which one it is though? A sum.
I made a mistake.
Mr. Judge, how are you gonna know which one it is? The sum is the second.
This is a sum of cubes. This is a difference of cubes. Correct. Okay. So this one is the sum of cubes, so we use this one. So we're going to do our 2 parentheses set.
You should go back and set a warning saying, don't leave early.
Right, don't leave early, exactly. Okay, so here it is. Plus is part of the problem. So plus, what goes here?
Plus.
Plus,
And a minus and a plus.
minus, plus goes here. Correct. Okay. Let's go. And recall what goes in the first slot?
X and 5.
Right, first term, second term. X and 5. Right, first term, second term. What goes here? First term squared. What goes in the last one?
25.
25, because it's second term squared. And what goes in the middle?
5x.
First times second is 5x. Okay?
The joke.
And now we're ready to set each term to zero, each factor to 0. So we go over here. What's wrong?
There's a rule for each one.
What's the question? Questions help. I like questions.
Oh, I don't know, what are you foiling to get, she doesn't get how you get each of the terms.
Each of these?
Yeah.
Okay, there's a pattern every time, and I'll write them in. This one is first term.
That was easy.
This is second term. Okay? First term, second term.
Yeah.
This one looks like first term squared.
That's like you just did
First term squared.
first 10.
Good.
This one is first times second.
Oh, you just follow the pattern.
Every time pattern, correct. And this one is second term squared. Second squared.
That looks like first term squid.
First term squid.
Draw squid.
Ink! Yeah. Alright, so let's set both factors to 0. X plus 5 equals 0. So that implies that x equals negative 5. Yeah. And now let's set the second term to 0. And I'm down to do a quadratic formula now. Let's do that.
Why would you do the first one?
Because it's even. This one's odd.
Okay.
Half squared would be more of a problem. Okay, so clean it up, make some room. Okay, I'm taking off your little things. Pause it at home if necessary.
Little things.
I took off the whole thing. Done! Alright, so x squared minus 5x
Plus 20.
plus 25 equals 0. Okay, x equals negative b plus or minus square root of b squared minus 4ac. All over what?
2a.
2a equals, what's negative b?
5.
5 plus or minus square root of, what's b squared?
25.
25 minus 4 times 1, I know, times 25,
Negative 100.
and then over 2. Yeah, I did kind of go through quadratic formula a bit fast. But yeah, it takes a little time to catch up.
But I think most of us already know quadratic formula, so it's
Right, so it's okay. Sorry, I'm just kind of, they call that
Sometimes they
setting.
don't know it, just
Yeah,
not a
just
fast writer.
setting the pace, right. 5 plus or minus.
Square root of 20.
25 minus 100 is negative 75.
there you go.
All over 2. Okay, and that up here. So what's the square root of negative 75?
25 and 3.
Right, so 25 and 3 inside. So 5i root 3, correct. So this becomes 5 plus or minus 5i root 3 all over 2. 2 answers here, and x equals negative 5 is the third answer. And out of the way here.
Earthquake.
Visually enjoyment. Okay. All right, ready for one more? Oh! Pull it off. I think I can pull that off. That's cool. All right, one more.
Yay, man, the
Wait.
What was the answer? 5 plus or minus? Write it down. 5i root 3 over 2. I don't want to be the teacher that erases things too soon.
That's so
Well, you've become one.
Well, I stopped. Because I learned. Yeah.
Stop halfway through.
Yeah.
It's like I almost killed the man.
Right. But he only ended up in the hospital. I feel okay. Okay. And why do I say that with an accent? I don't know. You end up in hospital.
A lot of things you do we don't know. It just, you gotta
It's just
go with it.
unexplained.
We just, sit back, laugh.
Right.
maybe some
Okay,
teaching.
last one. Let's make her count. Is this a sum or difference of cubes?
Difference.
Difference of cubes, is it true?
Yes.
Can we try this one on our own and then you'll do it on the board after?
No, we can't do that.
Wait, what did she say?
To try it on our own. I have an idea. I can give you problems to do within the comfort and safety of your home, and I won't say a word.
I really feel
I actually don't like that.
The whole time. I won't even call.
You're a very generous person.
Thank you. That was my idea.
There has to be a word for that.
Mr. Dude,
Is there a word for that?
I think so.
I think it ends with work though.
if we need help, can
I've
we
never
call
liked
the
anything
AML
that ends with work.
hotline?
Call the AMAT hotline. What's that number? Do you know it?
188. Yeah,
1888.
1-888 yay math.
Wait,
That's
there's
right.
like.
It goes straight to the cell.
Seriously?
Yeah.
For sure.
I have it.
And push on.
It's legit.
It's programmed in my cellular device.
Wait, are you kidding?
No.
Wait, so you put your number up for everybody?
Anyone who wants to get in touch with me, feel free.
So if I called it right now.
Anyone in the world. All right. What
It's
is?
beating on me.
Let's finish this out and then we'll talk after.
Would you put the 8 outside of
We'll
it?
talk
Do
after.
you have caller ID on it?
Yeah.
Oh.
Uh-oh. Wait, he doesn't have
We'll
our
talk
number.
after.
67.
Time out, friends. Let's get back.
Or time in.
Okay, time in. What is the sign string if it's a difference of cubes?
Plus.
Thank you.
What are you doing?
Okay. And what is the first term? What times itself 3 times is 8x cubed? What'd you say? 2x, right? What times itself is 27? 3 times 3. Okay. And now we put in our parentheses. Okay. Minus, what goes here?
Minus.
Minus, what goes here and here? Plus, plus. Okay. Try to be one step ahead. That'll be our compromise. One step ahead. What goes here?
2x minus 3.
2x. First term, second term. All right, let me ask you, young lady.
Okay.
What goes here?
It's the first term squared.
First term squared. What's the first term?
2x.
So what's 2x squared?
2x squared. Do you have to?
2x times 2x.
Oh, okay. So the 4x squared.
Good. 4x squared is right. Continue.
And
The
then
last one is second term squared. So what's that going to be?
9.
9. And this one is first times second.
6x.
6x. Okay. So we're on our way. Yes, please.
I don't get how you know if it's minus minus plus plus or plus plus minus.
All right. So let's put them in here. Plus, plus.
If it's a minus right there, then it's minus.
Here.
Minus plus plus.
Oh.
Yeah. This is a difference of cubes. This is a sum of cubes.
Wait, how did you get 9? If
9 is second
times
term
3.
squared. 3 squared. Second term squared. Okay, now we set both to 0. If we set this to 0, 2x minus 3, what is x equal to? No?
No, 3
3 halves positive. Good, almost. X equals 3 over 2. That's this one. And now let's jump right into this.
He was just kidding.
I know. I get it. Oh, negative 3 halves. Oh, because it's positive 3 halves. This is a good joke. Get it? Get it?
Good stuff.
Do that at dinner. Like one time it was negative 3 halves and I said positive. So it's like not really true. The end.
Sorry.
And then you say you had to be there.
My mom had this thing where she would tell stories at work and were from her job, you know? And she didn't know that it was just like you had to be there type of moment. And she would just get into it. She would just go and go at the dinner table and we're all like listening and just kind of smiling. And then the way she said it, it's like, and then we all laughed.
Do you remember yay math like dinner?
Okay. We need to, well, what do you want to do? Completing the square or quadratic?
Completely the square.
Completing the square? Alright, so first we have to divide both sides by 4 to clean this up. Or multiply both sides by 1/4. I'm going to do that. Alright, 1/4. 1/4. Alright, and then this becomes x squared plus 1/4 times 6 is 6 over 4, which simplifies to 3 over 2. X equals negative 9 over 4.
No, we should have just done quadratic.
Yeah, maybe.
I don't like fractions.
Let's do it. Fractions like you. What's half of this?
6.
3 over 4, right? The half of this is 3 over 4. If you multiply it by a half,
Oh yeah.
it'll be 3 over 4. So what's 3 over 4 squared then?
9/16.
9 over 16. So we add 9 over 16 to both sides.
Can we do quadratic?
You may. Don't feel bad. What's the problem? Let's talk. Half of this is 3 over 4. 3 halves times a half.
No, I understand how you got that. Just
You have to, the problem's not the fractions. The problem, in your case and with many other people, is the not knowing. The fraction's not the problem. Focus on fixing the problem, and then the fractions will be okay. Okay? I'm saying it's good. It's better to be in command than, oh, I want to avoid type of thing. Right? That's just my style of life.
He likes that.
Yes. Okay, now we can do this. Remember the rule. What goes in here is half of b. And what did we say half of b was? 3/4 goes in here. Okay. And now we need common denominator.
16.
So this multiplies by 4 and 4. Top and bottom. 4 and 4.
so negative 36 over 6.
Negative, yeah, right. Negative 36 over here. Plus 9 is
27. 16.
negative 27. Good job. Negative 27 over 16. Yeah, this one turned into a beast. We're almost done though. Square root both sides.
Oh my god.
And now we have x plus 3 over 4 equals, okay, so we have an I that comes out. Okay, so we do top and bottom square root. 16 is pretty easy. What's the square root of 16? So that's 4 out here in the bottom. And now we have to do the square root of negative 27. So we already took the I out.
9 and 3.
So square root of 9 times 3, so 3 comes out. So 3i
3.
root 3. And this is plus or minus. Okay? And then subtract 3 over 4 from both sides.
Oh lordy.
And you get,
Negative 3.
let's put it over here. Is this in the frame? Can you see this?
Yeah.
Okay. X equals, in the spirit of keeping it looking like quadratic formula, I'm going to put the negative 3 out in front. So negative 3 plus or minus 3i root 3
All over 4.
all over 4 because they already have the same denominator.
Well, you.
They didn't, you have to make them common denominator. Most of the time they do. This would be the result of quadratic, of course.
Yeah.
Of course, it would be the result of quadratic. You know, if I knew that this would happen, honestly, I would do quadratic formula too. I wouldn't do it just to do completing the square. That seemed to take the wind right out of your sails. Seriously, you guys are like, can we have a yay math dinner? Oh, fractions. Oh God. Oh my God. Oh.
Cool straw.
Thanks. It works. I got air. I've always wanted to do this to thwart criminals. You know, in the water, in the swamp.
Oh yeah. I saw that when I was little.
And I want this side out of the water. You
All you
know?
see is
I'm not here.
All you see is the tip of the straw.
Thanks for that. All right, say bye, everyone.
Bye.
Bye.
Bye, everyone.
Bye louder. How about that?
Bye,
Oh, you guys want free smoothie cards? For real?
Yeah.
Yeah, here, have one.
I got so many
Here.
yesterday.
Oh, you can't say smoothie. You have to say smoothie.
Smoothie.
Okay,
But
cut it
it's
off.
actually